Greetings, this is Decadat Outline Gabriel M, and we are the Group 3, and we are here to discuss you about in determining the procedures in using table and validate. Create a predefined route plan using the table and validate. Now, we have here passage plan. Passage plan or voyage plan is developed and used by a ship's bridge term to find the safest and the most favorable and economical route. The comprehensive plan, which covers the voyage from berth to berth and is adapted to the bridge management practices, should be detailed and easy to understand. Now, a passage plan should cover ocean, coastal, pilotage waters, and according to STCW regulations, be planned in advance. Now, passage plan. The following factors should be taken into account. First, the marine environment. Second, the adequacy and reliability of charted hydrographic data along the route. Third, the availability and reliability of navigational aids, coastal marks, lights, and radar conspicuous targets for positioning fixing along the route. Fourth, the type of cargo can influence route selection. Fifth, any routing constraints imposed by a ship, example, draught, type of cargo, and etc. And if possible, areas of defense, dense traffic. Take into account weather forecast, current tide, wind and swell, visibility conditions. If possible, avoided areas with onshore set or areas where onshore set can be expected. Now, passage plan. Whenever possible, follow traffic separation scheme and follow ship reporting procedures. Check technical systems before departure and, if possible, take into account previous experience of their reliability. Take into account your own experience with the planned route and type of ship. Passage plan. There are 4 stages for passage planning. First, we have here appraisal, the collection of information and validation of all relevant information. We have here also planning, the presentation of the raw data into information and the strategy to be used. Third, we have here execution, execution of tracking voyage and communication control. The last one, monitoring, ensuring that the voyage plan is being followed. Now, moving on, we have here the procedures in designing a predefined route plan. I will be discussing to you first the route. First, we need to find the information from all publications available. We can find it in our own admiralties aboard the vessel. And once we have all the information, we need to use that to decide the route. Now, in deciding the route, we must follow all the company requirements and must be in accordance with the industry guidelines by using our admiralty. How to create predefined route plan using the table and validate. Now, our first step on the route. On the top menu, go to Route. After, click Route Planning. Then click Graphical Editor. You'll see there, then it's just like drawing a route on a paper chart. Just take cursor on the starting point and keep on clicking wherever you wish to create a waypoint. When doing that, it should be easier to zoom out and choose a little smaller scale to get the idea of where we need to head to. And then you keep on zooming in and out and when required while creating the route. Once you have created the complete route, you can save the route. The waypoints created by the graphical editor would most likely be up to 3 decimal places. For ease of reference, you may want to change this waypoint to up to 1 decimal place. Now, for that, you can go to Route and click Route Planning. Then click Table Editor and open the recently saved route. from the table, you can find tune and waypoints. Now, for example, you can change the longitude 38 degrees, 57.999 degrees to 39 degrees. And that will be all for the first step. Now, moving on to the next purpose center, the step 2, route check.
Hi guys, so I am Lloyd Edison Oronan. So to continue, the second procedure in designing a predefined route plan is route check. So we must ensure that the route we have drawn does not cross through dangerous areas. But first, we must adjust the safer setting on ECDIS in accordance with our draft for the following voyage. So dapat agad ta sa kanang ECDIS nga gihatag ay sa draft nga gihatag before ta magkuan sa setting sa ECDIS. Then route check. So to the route planning table editor and open the route that you have created for the present voyage. So in the editor, enter the value of the cross-track error that you wish to have or what the company or masters allows. Then after, route check function will determine whether the path along with the cross-track distance passes across any navigational hazards. Then, for example, if the error is about caution area, check the detail of the caution area. Then after, this can be done by right-clicking on the ENC and choosing S57/C map/ARCS information and then clicking on the caution area symbol. So nasa kanang picture akong gi-provide. Then after, click the safety check button once we've input the cross-track distance for each leg. And then the ECDIS will inspect the route and display any faults that the user must physically see. This will direct the ECDIS to the section of the voyage plan where the fault was found. Then after the fault was found, modify the route if necessary after analyzing data, or else continue to the next error. Then after you've checked each error, select it and click disregarded. After you've double click all the mistakes, click OK to save the route. Then after you've successfully finished the route checks. So that's all about the route check.
So hello, good day. I am Carjo Pagmancao. So the third procedure in designing a predefined route plan is parallel indexing. From the route's fixed objects, parallel index distance must be marked. In the open sea, any fixed object with a range of 24 miles or less is a good choice for making the parallel index lines. So your radar in coastal seas will have a range of less than 12 miles. You can choose to mark parallel index lines from any stationary object within that range. Parallel indexing is not permitted with floating objects such as buoys, as well all know. So kanang first, to mark the parallel index lines, we use kanang nasa upper nasa kanang user map. So click nimo sa user map, na ang kuan user map editor. So pag click nimo sa user map editor, then ang next ana kay click on the new simple line and then take the cursor to the point which is landmark from where you want to draw the parallel index line. Draw the first line parallel to the course line and then 90 degrees to join it to the course line. So kana anang nasa tunga. So next, you can click the property on the right corner and change the line color and thickness, etc. kana nasa babaw upper right. So it is preferable for the PI line to be different color than the course line so that the navigator may clearly discern the course line during the voyage. That's all. Thank you.
Good day, everyone. I am John Simon Haba. This is the continuation report of Carl Jopet Mancao. So, the next slide, we need to write the parallel index. This stands for the PI that we have drawn just now. Next, click on New, then small text, and click at the location near to the PI line where you want the text to appear, and then write the text such as P.I.3.2 and M. So next, you can then click on OK and then save on the top menu. So let's proceed to the next slide. Just enter the name that you want to give to this user map, maybe the voyage number, and then click on Save to save the user map. Next, this same user map will be edited for all other markings that you need to plot on the ENCS. Next slide. Complete the voyage by drawing all parallel indexing lines and distances from any radar prominent solid objects.
Procedures in designing a predefined route plan. Fourth, no-go areas. We are required to mark the no-go areas along a route. These are the areas that are the danger to navigation and we must not navigate into. But let us say there is a wreck or shallow waters about 50 nautical miles from our route plan. Do we need to mark this as no-go area? Create predefined route plan using the table and validate. So, no-go areas. To mark the no-go area, go to user map. User map editor and open the user map that you have created for the present voyage. And by now, you should be able to create lines and shapes and add text in the user map. To mark the user map, you need to use these lines and shapes to mark the area as a no-go area. Use your artistic skills to decide which shape or line you need to use for marking of no-go area. And once marked, go to the property and change the line color, thickness, and etc. Again, use the color as something other than the course line, color, and thickness slightly lesser than the course line. And finally, write the text as a no-go area around the marked area.
Hi, I'm Alden Namawan. So the fifth procedure is wheel over position. Whenever there's a large alteration of the course, we need to mark a wheel over position. This is the position on our initial course at which we need to start altering the course at a pre-planned rate of the turn, arrive at the next desired course without turning into danger. Create predefined route plan using the table and validate wheel over position. Mark of wheel over position is part of the passage planning. But how to mark this on eclipse? This wheel over position depends upon the speed of the vessel and rate of turning alteration of course. As the turning of the ship is in form of an arc of a circle, there is another element that is involved, radius of turn. This is a relation between three terms: ROT, speed of the ship, radius of turn. While passage planning on eclipse, we need to define the value of radius of turn and ship speed at each leg. To do that, go the road planning table editor and open the route you created for the voyage. Under each waypoint, enter the value of turn rate and speed. This will create the arc of alteration of course for each leg in the road. But this is not enough. There is another element that we need to address. Once we put the rudder on one side to turn the vessel will take some time to start turning. We need to allow this while marking of the wheel over position. This information is provided in the maneuver booklet and is given in terms of distance moved as the length of the shift before vessel start turning. It is generally between 1 to 2 length of shift. The wheel over position need to be marked at a distance by that much from the start of the course alteration arc. It may not be possible to measure that small distance, but just make sure it is justifiable and to mark that we need to edit the same user chart that we need created for the voyage. We have already discussed about editing the user chart. Here is how marking of the wheel over line would look like. Wheel over range and bearing. If there is a fixed object near the wheel over position from which rudder bearing range or visual bearing can be taken, we need to define the wheel over position with respect to bearing range from this object. Again, the marking of this line will be by editing the same user chart. Then we need to draw a line from the fixed object to wheel over position and measure the bearing and distance for wheel over position to fixed object. We can edit the user chart further to write the text with information about bearing and distance.
So, good day everyone. I'm Bryce Lloyd Narciso, and I'll be reporting the sixth procedure. So, the sixth procedure in designing a predefined route plan is abort point and point of no return. So, first of all, what is abort point and point of no return? So, abort point is the point on the passage beyond which there is no sufficiency room to turn back the vessel. So when approaching or entering a port or proceeding in a channel, the width of the channel may not be sufficient to turn the vessel. So the point where width of the channel becomes narrow enough that vessel cannot make turn would be called abort point. So muna siya ang abort point. So ang point of no return is not related to width of the channel or turning of the vessel. So with point of no return, there may be sufficiency room to turn the vessel, but the vessel cannot return to where it came from because the conditions have now changed. So one example of point of no return is while proceeding in a river with falling tide. So if the next port is changed or cancelled after passing the point of no return, the vessel cannot return back because the tide now will be less than it was few hours earlier. So when vessel pass the same location, in this case vessel can turn and there is no issue with the turning back and maybe anchoring. So it will not be called abort point, but it will be called point of no return. So while entering a port, if we try to swing back after we have passed the abort point, we may end up grounding the vessel. So or we may end up hitting a danger mark. So marking of abort point on ECDIS is not different than marking on a paper chart, except here again we'll use the user chart option for making instead of pencil. So that's all.
Good day, Sir Dax. I'm Cadet Ayan Sigun Magalion, and I'm here to tackle about the 7 procedures in designing a pre-defined route plan, which is position plotting interval. Position plotting interval is the maximum interval between two position fixes. So if in a particular section of the passage, we have agreed the PFI of 0-1 hours, we must plot the ship's position at least every hour. During the passage planning, we need to decide the position plotting interval and methods. And it's create predefined route plan using the table and validate position plotting interval. During the passage planning, we need to decide the position plotting interval and methods. Second, this information needs to be provided at each leg of the route. And last, on ECDIS, we just need to edit the same user chart to include the text about position plotting interval and the methods at.
So, good afternoon, sir. I am James Carl Morales, and I am the last reporter. I will continue the report of procedures in designing a predefined route plan. So this is the number 8, other information. So then there is other information that we need to write on the ECDIS. These include watch levels, contingency anchorages, security levels and hardening measures, reporting requirements, calling the muster, and also the point at which notice to be given to engine room. So next slide, please. First, we have the watch levels. This requires a watch keeping. And also, next is the contingency anchorages. So, contingency anchorages is a safe anchorage place which is available during the voyage. So, in other words, a place where ship can be safely anchored in case of an emergency during the voyage. So next is the security level. So we have these 3 security level, which is ISPS security level 1, which is normal, security level 2 is heightened, and security level 3 is exceptional. So also we have the system hardening, which is a collection of tools, techniques, and best practices to reduce vulnerability in technology applications, systems, infrastructures, firmware, and other areas. So next is we have the reporting requirements. This includes the use to provide, gather, or exchange information through ledger reports. And also we have called the muster. When calling the muster, it is used in case of an emergency or when in doubt about a particular situation. And also, we have the point at which notice to be given to engine room. So, the chief engineer take a quick round of engine room to be taken by a chief engineer to be reported regarding the departure. And that's all, sir. Thank you.